This video is divided into 3 sections. One, where we will import our attacking animations and code it into our player. Second, where we will add our hurtboxes and hitboxes to actually register our attacks and damage. And finally, the third part, where we will add the game juice to our attacks. That is camera shake, camera zoom, in order to make our attacks punchy and satisfying to hit. Okay, let's start. First, let us import our punch and kick sprites from our asset pack. These sprites will be used to make our animations later on. Adding sprites is a very simple process using animated sprite 2D. Interesting things happen when we start writing our animations. Starting now, we have two main attacks, namely punch and kick. For punch, I envision it to be a very quick attack with a low damage. By quick attack, I mean that it has a very small startup and recover window. Post-edit with here. Some of you may not know what a startup or a recover window is, so here's a quick small guide. Startup window or startup frames are the frames required to start any action, which in this case is a punch. I mean, you do it in your real life as well. Imagine yourself punching. You just don't go shush and punch. You first wind your hand back, tuck in your elbow, and then punch. This is essentially your startup frame. Our player will have something like this as well. Now, recover frames on the other hand are the frames required by the player to recover after performing certain action, which again is our attack here. Again, referring back to our previous example, after you punch, you just do not go back to normal. I mean, you take in a few short breaths, put your shoulder back in the correct position, and yada yada. Our player will again do the same. Startup and recover frames are essentially there for you to get punished for spamming your attacks, as we are pretty vulnerable to incoming attacks during this phase. Okay, back to the video. Kick, on the other hand, I envision it to be a very slow attack with a high damage output. Again, by slow, I mean that it has a very large startup and recover window. You will see both of these in details when we wire our animations. Now, let us add in our punch animation. Notice that the animation is 3 frames long. The first is our startup frame, the second, our active, and the last one, our recover frame. Now, moving on to our kick animation. Here now, you will notice a stark difference between the animation lengths of these two attacks. As you can see, the kick is nearly double our punch animation's length, with the first 2 frames being our starter frames, the next 2 our active frames, and the last 2 our recover frames, making this a slower attack as compared to our punch. With this, our animation is done. Now, let us move on to the coding part. The coding actually is pretty much same to what we did in our previous videos, with just a small caveat which I will mention later on. First, let us go over our punch state. First, let us do the prerequisites. I mean, I sound like a broken record at this time, as I have repeated this over and over again. First, add in our punch animation's name as a variable, then the punch state, and finally, the input mapping. That is the button that will actually cause us to punch. Now, here is our basic punch script that we will edit. This script is pretty much similar to what we have done previously. We play our animation when we enter our state, and these are the states that we will transition to once our punch stops. The only difference is how do we know when our punch has stopped. For this, we make a variable called #attacked. That is initially false and will only become true once our punch animation ends, indicating that our punch has stopped. Once we have attacked, we will automatically go to our idle state, or to any other state if we have pressed the corresponding action key. Wire the transition to our punch to our idle and walk state, and yeah, we can punch. Kick state is the same as our punch state. Nothing much to narrate, you have seen all of this just a minute before. Instead, I would like to take this opportunity and ask you a little question about the channel. You see, this series is pretty much at the end. I will just make one more video about pain and death state, and that is pretty much it. My question is, what about later? Do I go back to making my devlogs of the video games I have made? And I assure you there are tons of good projects that I want to make and show you guys. Or I pick up another tutorial series and make tutorials on them, namely making a retro 3D FPS on Godot, similar to the likes of Doom or Quake. Please mention your thoughts down below in the comment section. Anyways, on to the video. For our hitboxes and hurtboxes, we will define 2 area 2D class scripts, one being the hitbox and the other being the hurtbox. The logic behind the hitbox and hurtbox is that Our hitboxes lie in certain collision layers, and our hurtboxes listen to these collision layers. So, whenever these two boxes collide, the hurtbox gets a signal that something has entered its area. That something is our hitbox. Once registered, we deal the damage to the owner of the corresponding hitbox. So, the code is pretty simple. In our hitbox, we will define its collision layer to be 2 and its collision mask to be 0. That is, it has no collision mask. 2 is just any random collision layer that I decided on the fly. Our hurtbox will be just the reverse. That is, its collision mask will be 2, while its collision layer will be 0. Next, we will define a function that will run when someone has entered the area of the hurtbox, and if that entered area is a hitbox, we will deal damage to it. The exact logic of dealing damage to the player will be done in the next video, along with the pain and the death state. For now, we can just print to the console that the damage has been dealt. Now, all you have to do is to define our hitboxes inside our punch and kick state, and only make them active during the corresponding active frames of our animations. Everywhere else, they will be disabled. To test our hitboxes, let me make a dummy hurtbox inside the level, and yeah, we are dealing damage. Except for one small thing, our hitboxes are not rotating with the player. That is, they are only facing the right direction. The fix for it is pretty simple. If our player is flipped during the entrance of our attacking state, we will change the X component of our hitbox's scale to -1 or to +1 otherwise. And with this, we can now deal damage. Well, there are various aspects to game juice. Here, in this section, we will look at 2 of them. They are very low effort, but in my opinion, improve the enjoyability of our game tremendously. These are camera shake and camera zoom, and we will use the camera nodes, zoom and offset property to manipulate them. Both of them have the default value of vector 1 and vector 0 respectively. So, let us define them in our camera class. During the start of our game, we want our camera to inherit these values. Next, we will write 2 variables representing our current zoom and shake levels. 2 float variables that will determine the factor by which we will change our current zoom and offset variables to their initial values. First, let us look at our camera zoom code first, as it is relatively simpler. Every frame, we will lerp our current zoom, the initial zoom value, using our frame delta multiplied by our zoom recover factor as the step, and then assign this value to our actual camera zoom property. How it works is that majority of times our camera zoom and our current zoom will be same. So essentially, this code will have no effect. However, when we change our current zoom to something else, this function will kick in. Namely, we will lerp our current zoom back to its initial value using our step. This way, over time, our current zoom will become equal to its initial zoom value, bringing our camera back to normal. We will make a small function that will be called by other bodies to change our current zoom variable. Now, to use this code, I firstly add our camera into a group. Next, add this camera's entry into our player state class. Next, when we punch or kick, I just call the zoom function and change its value to be something greater than 1. Now, we test the code. And voila, everything is working. Now, on the screen shake. The setup is pretty much similar to our camera zoom code. So I'll just explain the logic behind camera shake. During our recovery phase, that is from any given offset value to the initial one, we will randomly vary our offset across its positive and negative scale along both of our X and Y components. This will make our camera teleport to random points in every frame, simulating a shaky effect, which is our camera shake. Adding this to our punch and kick script, and voila, we have camera shake. With this, we have pretty much covered everything that I wanted to discuss in this video. If you are curious of what the final result of this video series would be, check this video out, or this one if you want its 3D version. Until then, bye bye.